Thank you for joining the September 24th, 2019 VOLTHA call. Just a reminder to everyone that these meetings are public and recorded, and we post them to YouTube. So please be mindful of that during the discussions and any presentations that we have today. And with that, we'll go ahead and get started with today's meeting. Ken, are you on the audio at this point?
Yes, I am. Can you hear me?
Yes, I can. Thanks.
Okay.
So first on the agenda today, we have a continuation of Thursday's discussion on the presentation that Ken had, or the proposal he had submitted on device states and transitions. And then following that, I think that will probably take up a good portion of time. We're moving to our new format for the Tuesday calls, where we're going to be looking to have brigade updates. So this is our first attempt at introducing that on this agenda. And then we'll be looking at new JIRAs with remaining time. And a reminder that now on the Tuesday calls, we're going to be focusing on issues that are not related to an active brigade. So we would expect new JIRAs that are related to brigades to be covered during those meetings rather than this call, unless the brigade lead, for example, recommends that we have a group discussion on the Tuesday meeting. Okay, with that, let's go ahead and go into our first topic for today. Ken, would you like me to give you presentation rights?
Yeah, sure.
Okay.
Okay.
We can see the screen. Thanks.
Okay. Is it big enough?
For me, it is fine.
Oh, okay. So this is a follow-up of last week meetings. We had a lot of discussions about state, device state in the call. So I updated the document that I showed last week with what we discussed. And the question that we had, some of the questions that we had in the document were not addressed last week because we didn't get to there. So hopefully we'll get there today. Okay, so I'll just go briefly over the changes that we talked about last week. In terms of device states, we'll have really two states, the admin state and operation state. The admin state will only be enabled and disabled, and operational state will be unknown, pre-provision, activating, discovered, active, failed, and unreachable. And then we'll have an operational status. We just talked about status. We didn't put a name there, but I just put the operational status because we needed a placeholder for downloading images. So I put that there. In terms of port states, so the admin state will remain as enabled and disabled, and the operational state, we will need a new enum for that, and that will be only unknown and active. While I was doing this, I have a question. It's since we have operational status there, downloading image, do we need an operational status which is the default? For instance, if the device is not downloading images, what should be that operational status? Should be something like a none? Any idea on that?
I thought we had operational status as it could be multiple, essentially flags, bit flags, and downloading image was one of them.
Yeah, it could be multiple flags. Like I'm just looking for a default one.
Well, if they're flags, is default 0, I guess is my question, right? No flag set would be the default if it's not doing anything.
I guess, what do we call that, though? Do we call that an empty string?
Yeah. Yes. Or, I mean, unless we want to say, look, 0 is going to be the running, operational status, I'm running. It might be just an empty string. right, is 0, and nothing. It's no additional operational states happening.
Okay.
Unless you want like one passing traffic.
No.
How about idle?
It's not really idle.
No.
I mean,
What is
running
it,
is probably the best name I could think of. But I mean,
Well, it's.
I mean, is blank even an option? Is that even viable in this situation with protos and the setup?
Well, what kind of field is it? Is this a string field, or is this like a bit field that we're just stuffing bits into, or?
It would be an enum, so pretty much it would be 0, 1, 2, 3.
I thought it was a bit set because you could be downloading image and doing something else at the same time.
I think this should
just a purely operational status. It can be, but you can be your state can be active, and then you're downloading image.
Right, but presumably the thing could be doing multiple things, right? It could be saying. Yep. It could be passing traffic and downloading image, or it could be probably, So the question is, right now we only have one operational state, i.e., among other things, I'm also downloading an image. But even if we don't have one today, there's going to be a one tomorrow, perhaps. So I don't think we can say it's anything num. It's got to be a bit field. And then the question is, if there aren't any other interesting things happening on the device at the same time, is the operational state just empty? Or do we do something like normal?
Does Proto have a bit field? Is there a way to model that there? I've never tried.
You just use an int, unsigned int.
I think we could make it a bit field because we use bit fields for port states, I believe. So we could model that.
Yeah, I'm just Googling. I don't see any formal bit field in protobuf, unless I'm just not finding it. But it just seems like, an unsigned 32-bit integer, and 0 is when nothing is set.
Yeah, it would be an integer, and then we'll have to use it as a bit field.
Yeah, I mean, we're doing that with flows too, some places, I believe.
Yeah, we are, actually. Okay, cool.
So we're back to your original question, though. What do we do if we don't have anything? Do we leave it as 0 and leave that blank, or do we?
I think I'll leave it at 0, since it would be an integer, so I'll leave it at 0.
And then 0 means blank.
Yeah, 0 means nothing.
It works for me. My hero 0.
The only other comment I had on the port state is for operational state. I think a third one is needed, something to distinction between unknown and inactive or down, or something that's different than active and unknown. I'm not sure if I think unknown again implies I have no idea, whereas inactive is I know there's nothing plugged in, kind of a situation.
Yeah, I think it makes sense because today we interpret unknown as down, which is not really correct.
Right.
Okay, I'll add inactive.
Should operational status be operational flags?
Yep. Whatever name we want it.
Okay. It's a minor thing. It's not quite a state like the other ones. It's just a set of flags. That's all.
Mm-hmm. Yeah. At this time, it's very easy to change. It's only in the document. Any other comments on this table? Okay, I tried to draw it. I didn't put all the different states that we have for devices. I just to a level setting on what we talked last week. Pretty much when the very first time that we pre-provision a device, the admin state will be disabled and operation state will be pre-provisioned. When we enable it, it will move to enabled and activating. And then depending on what we get back from the adapters, it can go to enable active, which is a good case. It could go to enable failed, or it could go to enable unreachable. And then over time, like if it's failed, is there an actions that the adapters needs to do to get to that state where it's active, or is it something that the core needs to do to get it to that state of active? Any thoughts on that?
Operational active, I think for OLT, that's when it's successfully connected gRPC and is able to talk to the agent. Or, well, there might be one in between active. There might be like discovering and then active. I'd have to go back and look. For O and U, it goes through the same thing, where it'll go through an activating and then a discovering and then an active. But in all cases, it's the adapter talking to either the agent or the adapter talking to OMCI to determine what active means to it.
So are you saying like some of the states will just not happen? For example, enable failed or enable unreachable during the...
It may be that in attempting to connect to the agent and it's not able to, it would go enabled unreachable or enable failed. Enable unreachable if it literally couldn't reach the agent, and then enabled failed if it maybe could reach the agent, but then the agent returned something saying, you know, the hardware's not ready. But I think in all cases, it's the adapter and then the agent deciding that state. The core is just consuming what it's been told.
Yeah, that's correct. But my question is, if the adapter reports that is, for example, enable failed or enable unreachable, should the core do further actions on that?
It may be that in the case of the parent-child relationship, the core needs to assume something on the child devices in that case. If, let's say, it's unreachable or failed, it may need to force all the O and U or child devices to unreachable.
Okay.
I'm thinking out loud. I'm trying to decide if that's the right approach. It may be that it's the OLT's job, the OLT adapter's job to do that, because the OLT adapter is still in play. So it would be, it might be more appropriate for it to change that state.
We talked about separating who was in charge of that field.
I think admin state is clearly core. Operational state, I guess it's a question of, do we want the core to make some assumptions sometimes, or do you just want the adapters to always decide? And it may be that if you can't reach the adapters, the only time the core has to make a decision on the operational state. But if you can reach the adapter, then the core doesn't mess with operational state. Does that make sense?
Yeah, that's...
The last, I think when we spoke about this, I think what we were talking about was that the adapter of a device is in charge of the operational state of the device. But as Matt, you pointed out right now, right, in case of unreachability, the parent has to update the operational state of the child device, or at least let the child device adapter know that it has become unreachable.
But in both cases, it's still in the realm of the adapter to sort itself out.
Yes, still in the realm of the adapters.
So I think in this case, let's say let's say the OLT adapter went away, but the ONU adapter didn't go away, might be a scenario where the core might have to make an assumption on behalf of the OLT adapter. And then if the ONU adapter goes away, the OLT adapter is in a position to, for the child device, decide the operational state.
So ideally, each device should be able to, or each adapter should be able to figure out if it is able to reach its device or not. And I think even in the ONU adapter, there was effort to do that with the health check mechanism that was being implemented, but I don't think it exists fully as of today. So should we be thinking on those lines, saying that each device adapter should really figure out its reachability to its device, and only in situations where it can't, maybe the parent helps out or some other component helps out?
Isn't it so that in case of ONU, the OMCI state machine will detect a timeout kind of thing?
I don't think that's implemented right now. There is some piece of it, but I don't think that's working.
So right now what will happen is if, let's say, the OLT hardware goes away, the OLT adapter will send an indication, I think it'll get an indication that from the agent, if the agent's still there to send the indication, it'll send an indication that ONU's down and tell the adapter. If the agent completely goes away, there might need to be something in the OLT adapter to send the same call to the ONU adapter saying basically the same thing, ONU is gone. But in both cases, it's in the realm of the adapters to sort itself out. I think the question really is if one or more adapters go away, whose job is it?
Yeah, so Matt, I was just looking at the OMCI, Broadcom Open OMCI ONU code, and there is a heartbeat file. So let's say the agent goes down, so the OMCI messages will not go through, right? So the OMCI will declare a heartbeat failure, and maybe that might be a place to inform the adapter that the ONU is not reachable.
Yeah, I think that's fair. So let the ONU just keep track of that as part of its heartbeats.
Right.
Okay.
Yeah,
so what I'm hearing is the only time in this scenario the core will be able to do something if when an adapter reports the device that's enabled and unreachable. If it's unreachable, then if it's a parent device, you will have to tell the child device it's unreachable. Is that what we're trying to agree on?
I think what it sounds like is if the child device is polling or doing heartbeats for its own connectivity, itself will find out that the parent is gone by virtue of the proxying no longer working, and it will update its own operational state in the core. I think the scenario now really is if both adapters go away, then it's really the core is the last option to set the operational state.
Okay.
So maybe in a tree of adapters, we have the parent and then multiple children. If the parent and the parent and a child both go away, then the core has to say, all right, I've got to decide for you. If the parent and the child if the parent's gone but the children are still there, the child should at least be able to inform the core via a heartbeat mechanism. And of course, if parent and children are all gone, then of course the core is the only one left.
And can the core set the operational state to anything but unknown or unreachable type of thing? I mean, it can never accurately set it.
Yeah, what was the distinction last week? We said unknown was I couldn't get to the adapter, and unreachable was the adapter couldn't get to the device.
Yeah.
Yeah.
So if the core is going to set it, all it can do is set it to unknown.
I think so.
So Matt, I have a question regarding the heartbeat of the ONU using OMCI. So there is some piece of code that exists, but it's not being exercised. Anyone has a clue as to why that is so?
Haven't got around to it.
Amit, do you mean that the heartbeat is not being performed in OMCI?
Yeah, that is what I could see in the code.
Okay.
exists, but it's not exercising the heartbeat.
Yeah, because the heartbeat thread seems to be updating the device status and whatnot on failure. But yeah, maybe we could explore enabling that code.
Yeah,
Yeah,
so
it was
that's
probably just due to
what I'm
lack
trying to
of.
get to. Is there a specific reason why that is not being exercised? Is there any history behind it?
No, none that I can think of, other than just
No idea.
it wasn't done. I mean, it probably just needs a story and just get implemented.
Okay.
Okay, so
I mean,
Matt, I also have a comment about this detection of the ONU adapter for each ONUs. We should also think the messaging between the adapters and core in case of an OLT adapter. If ONU in case of OLT restart, if ONU adapter detects all ONUs and send messages to core for status update, that means that thousands of messages in a time from ONU adapter to core.
True. So now it's a question of, does the core make assumptions based on a parent for the children to save on messaging? I guess that's the question.
Yes, in messaging manner, it's you can send only one message from OLT adapter to core, and according to this, you can do that thing. But I don't know if you should, inform the ONU adapter for that also.
if there's a message that's coming to the core from the OLT adapter saying the state of the ONUs have changed, for example, they are unreachable, the core will interpret it as, okay, so the OLT cannot reach it, but it will still need to inform the ONU adapter that those devices are unreachable. So there will still be messages being sent on Kafka to the ONU adapter today. Doesn't mean that's the way to do it, but that's how it is today. So far what I got, it's if all the adapters are gone, there's no communication between the core and the adapters, then the core will change the operational state of all devices to unknown and leave the admin state to whatever it was.
Yeah, I think that's the easiest failure scenario right now, is all adapters went away, and then the core has to do something. Mm-hmm. I think where we're left with now is if there's a mix of parent and child adapters going away, who does what for the sake of efficiency and responsibility. Yeah, it sounds like we kind of could go back and forth on that one. So maybe for now, if we leave it in the adapter just because the adapter should be able to take care of its own, we could do that, and then maybe explore some way of, if the OLT adapter itself can make a decision on behalf of the children, there's some way to suppress all of the children from sending that notification.
Yeah, at some level, that's an optimization, right? Can we get it working even without the optimization, and then perhaps optimize it?
That makes sense. And one way could be, maybe we could add a new API in the core that updates the oper state of all child devices for a particular root device, and the control of invoking this API lies with the adapter. Instead of having core take a decision on its own, it could be the OLT adapter invoking that API and forcing the oper state of all child adapters to, let's say, unreachable or whatever.
Yeah, that API exists today, so it will be easy to do that.
Right.
So on that diagram that you can see, like the only combination of state for the OLT that won't make sense would be enable and discovered. Enable as admin state and operation state are discovered. All the other states are valid transition. including enable unknown, like what we said is when all the adapters are gone, they will go to enable unknown. In terms of the ONU transitions, it's really like we'll get a notification from the adapter saying that it has discovered a child device. So the first state, it will get created, that child device will get created inside the core. Admin state will be disabled to be consistent with the OLT creation. And the operational state in this case will be discovered. And the transition to enable it, currently it's automatic. Like the moment we get something discovered, we enable it, means we send an adopt request to the ONU adapter, and we'll change the admin state to enable and operational state to activating, and the rest remain pretty much the same. I believe we still want that automatic processing, right? A child discovered coming in, and the core goes and enable it. Any thoughts on that? We'll leave it as is, no change.
Yeah, this gets kind of into some of the different operator default behaviors. You know, if by default, nobody wants any ONUs to go active unless some northbound API administratively says make an ONU active. I mean, for the sake of progress, I'd say let's leave that the way it is. But there may be a scenario where we may want to have all ONUs start up as disabled by default,
and require a explicit enable from the operator.
Yeah, maybe this kind of aligns with some of the whitelist stuff in SIBA or I guess anywhere else where you might want to have an explicit set of ONUs you want to enable, and if some ONU shows up you know nothing about, it starts off as disabled, and there's never even a chance for it to go any further.
Oh, okay. Okay, cool.
So Matt, would the intention be to really have it disabled on the PON, or because anyways there won't be any flows provisioned on the device, so even if they are active on the PON, they can pass traffic, right?
Yeah, I mean, some of it is kind of semantics, right? It's unusable anyway. Yeah. It's more of a question of now, does the OLT take action to prevent that ONU from trying to do anything on the PON, maybe stuff it shouldn't be doing, like, you know, maybe it can't pass traffic, but it can flood PLOM messages or some other, you know, nefarious activity.
Yeah, that's true.
Yeah, so as long as it's enabled, it's consuming PON resources. So I think it needs more discussion, but as Matt said, for the sake of progress, probably leave it as it is. And
yeah, I think so.
Okay, it could also easily be changed to be configurable. Like it will be a flag to make it automatic or not. So any questions on those diagram before I go to the table again? Okay, I'm just going to move to the table. I'm not going to go through all the different transitions for the sake of time. I'm just going to places where we have actual have questions, and that has been raised. So here's a scenario where we are disabling a device. So the user disable a device. So pretty much the admin state is the only one that gets changed by the core. It could be any admin state. It goes to disabled, and operational state, and that doesn't get changed. And obviously here it's you can't disable a device that is only in pre-provision state. Nobody has done anything about it.
When you say the word unchanged, I guess that's code for it's responsibility of the adapter to change that, right?
Correct, not the core. So during that when we disable, so the core will send a disable request either to the parent or a child device, depending what we are doing. But it does something specific for if it's a parent device that we're disabling. there are different ways of doing that. It's either the core taking over in a sense of it sends a disable to the parent device and automatically set all the child device as unreachable, or like the OpenOLT is doing it today, where the OpenOLT itself send an unreachable indication to the ONU devices. Do we want the core to be involved there, or we want the adapters to take over it, especially for a parent device?
What did we say earlier? I think the only way the core decides is if the parent device goes away. If the parent device, the parent adapter is still around, it's between the parent and the children to sort out their operational state and just report back to the core. Right. That's basically what we said earlier.
Mm-hmm. So pretty much on a disable, even if it's a parent device, the core doesn't do anything with the child device, unless all the adapters are gone.
I think maybe the core would set admin state of parent and child to disabled. It's now up to either parent or child or some negotiation between them to set the operational state appropriately.
Okay, so
yeah, core can only set admin state. The adapters have to deal with the operational state.
Yeah. So in this scenario, that if I admin down an OLT, it implies the explicit adminning down of all the ONUs.
okay.
Is that right? I mean, why should the ONU's admin state be disabled? They would just go unreachable.
Okay.
I always go back to, if I'm on a physical switch and I admin down the switch, is that the equivalent of admin downing the ports?
I don't know. I was just thinking.
I thought it was before it was the core was actually changing it, changing the child device to disable as well, and then I think it has to go back. We removed that. I think the word transition that was getting flows either deleted on the child device, or there was action that were being done on the child device that were not really required because of that disabling.
I mean, the problem I have with disable the OLT, admin down the OLT forces admin down on all the ports is, well, when I admin up the OLT, do I admin up all the ports? Right? It's not reversible in some sense easily. And I'm not sure that makes sense.
All right. Well, I mean, so I guess practically speaking, if we admin down the OLT and then leave the admin state of the ONUs, whatever they are, their operational state would have to go unreachable. And then when you admin back up the OLT, the ONUs
should come back up.
What'll happen? What'll happen? The OLT should send some indication to the ONU adapter, OLT adapter, the ONU adapter saying I've received indications again, or
yeah.
I don't know.
The other question is, if I admin down the OLT, do I expect all traffic on the ONUs to stop?
Yes. Yes, because as part of the disable of the OLT, I think the current behavior is to disable the NNI port. We are discussing to change it to disable all the PON ports, but either way, the traffic is going to stop for all the users.
And I think disabling the PON port would be good, because then it would force a renegotiation of the ONUs anyway, which will force the ONUs to have to renegotiate, set themselves back up again. Right? You would get new indications at that point, I think.
Exactly. Yeah, so there is also a technical problem with disabling the ONUs when you disable the OLT, because it sends a OMC admin state lock which never reached the ONU because you have disabled the OLT. So just marking the child devices as unreachable should be good enough.
Yeah, I think so too. Okay, so maybe we leave the admin state of the children alone, and it's really just up to the parent adapter through its communication channel to the children, in this case indications, to restore traffic or restore communications on the PON port.
Okay, so if we do a disabled, the admin state will go down for the OLT, will be disabled, and the adapters will come back up and change the operational state of the child devices to unreachable, and it will also disable the PON port automatically?
Good question.
Yeah, for disable OLT, it should disable the PON port on ports.
Yeah.
Okay.
It doesn't do it currently, but that's what we intend to do.
Yeah, the port states are one place where we really haven't done anything clever, but we should. I think in terms of operational state, yes, all the PON ports should go operational down. In terms of their admin state, both on the PON port and the uni ports on the ONU, I think, again, it should be left as whatever they were before is what they are when they come back. But operational state across all the ports should be now down, or whatever we call port down.
And that will be set by the adapter?
Yes.
Yeah.
Okay. So that answered that questions. Currently, we have a couple of APIs. I don't know if it's actually being used or not. There's child devices lost, child devices detected. I don't know if any of those are being used, but just for the sake of discussion, I'm just going to skip over those because it's not as important.
That's just the plural version, right? That's the all exactly. Of them. Okay.
Yeah, this is really after a re-enable of a device. During that, or disable of a device or re-enable of a device. It's OpenOLT are not using them. That's why I put like, do we really need them or not? But let's go to the next one. When we do a device reboot, is there any, first, are we expecting any state transition that needs to happen? And should, on the reboot, should flows be pushed to the devices?
So reboot shouldn't be any different than just an operational state change, right? Reboot really is just some communication channel directly to the device saying, unplug yourself and plug yourself back in. So from the point of view of the core, it shouldn't do anything different other than if it just went unreachable and then reachable again, to me.
Okay, so
yeah, you expect the flows to be withdrawn and then re-added once authentication occurs, right?
Okay.
So I feel there is a,
go ahead.
Sorry, I think there is a difference between plug-in, plug-out, and reboot. In case of plug-in, plug-out, the device still has a flows, but in case of reboot of the device doesn't have a flow. So that's the difference. I think that is what we need to address, isn't it?
Okay, well, I guess maybe a better way to say it is reboot as a command sent from northbound, and then a power cycle from the point of view of the core look the same.
Okay. So it
I
will be
guess
like
better way to describe it.
Okay.
So I don't know. I guess on reboot, I don't know if the core should explicitly change any states. If the reboot command is set down, it would again be left up to the adapters who delivered the reboot command to then turn around and update state the same way they would if the physical device went away.
Well, a reboot is just triggering some action, right? So it as part of that action, that something should go down and then come back up again. If the reboot is ignored or it's lost, then nothing will change, right? So the state would remain the same.
Yes. Yeah.
is there a transition that needs to happen to force the flows to come down from owners for those devices?
So, so on the logical plane, the ports should go down, right? So the logical port should go disabled in the logical plane.
Okay.
And yeah, and that should trigger the ONOS application to withdraw the flow rules.
Okay. So for the logical port to be down, there should be a state transition of that device to put it in that state.
Yes.
So will the adapter report a port state change during a reboot?
Yes, I think so, because what will happen is let's say just OMCI example, because that's the one that's in my head. We send the reboot command via the OMCI channel. The adapter delivers it and again does nothing at that point other than just faithfully deliver the message. At some point, milliseconds later, the device went away. The adapter notices that and does whatever it would do if the device went away anyway. It's just now the success of that reboot has now been realized by the adapter as the communication channel went down. And then report north, the operational status of the ONU device is unreachable and the operational status of the ports are down, which should then trigger logical devices and ONOS to behave the way they need to.
Right. I mean, the fact that you send a reboot shouldn't cause anything to happen except that the receiving device that gets the reboot will take action on that. If the reboot is lost, then nothing will change.
Right. What most will happen is all the oper states, may or may stay the same, but really it's just the adapter will say, I tried to send reboot and I couldn't. Reboot failed, and at that point, it's likely other things may start failing as well. But the act of the ports going down or the device going down operationally would only happen if the device at that point gets the reboot command and takes itself away.
Okay.
Which I think comes back to reboot and device restart on its own from the point of view of the core are no different. It's just operational status is now down, and then repush flows when it comes back up, both port and device.
Okay. This is so there's no change to existing behavior. Have we ever tried the reboot on an OpenOLT device?
Reboot on OpenOLT device, I think, literally sends a shutdown -R to Open Network Linux on the edge core. So in that case, it's just like the OLT got powered off. Reboot on the ONU is the same thing. It literally just restarts the box and it boots back up again fresh.
Yeah, I'm just wondering if we have seen that behavior where we see flows coming down after a reboot.
So this is kind of a issue we're dealing with now, where on a reboot right now, the flows that come back down are just the EPOL authentication flows to the ONU. But on the OLT, it repushes its subscriber flows itself. ONOS, in this case, only sends down the EAP flows, but the OLT, I think, remembers that it has subscriber flows, pushes those. The ONU says, I was only told to push an EAP flow, so it just pushed an EAP flow. So there's kind of a mismatch in the behavior right now, but basically because the OLT, I think, is remembering and repushing down its subscriber flows, but the ONU is not. Maybe what we need to do is, in all cases, send a bulk update and let the adapters sort out whether or not they need to take action on it or not.
So Matt, on this, I think we need to cross-check on the behavior of the ONOS app as to why it takes away only the EPOL flow when the logical port is disabled and not all the flows. Again, I don't know the history as to why that is the behavior. But yeah, I really don't understand this.
Yeah, so this is actually a good question, because I thought between 1.6 and 1.7, I think with 1.6, the ONOS apps behaved one way, and with 1.7, I think it's now, like you say, in terms of whether it makes sense or not, yeah. I think it should, if the device goes down, I think it should pull EAP flow and subscriber flow. And then when it comes back up, I guess it's a question of, do we want to just repush just the EAP flow or both the EAP and subscriber flow? If we repush the EAP and subscriber flow, that implies, well, I mean, again, it's like now, do we wait for EAP authentication to happen again to then push the subscriber flow? Do we want EAP to happen again?
Given that we have in the core, those flows would be the most current one. With those actions, do we want to have like an additional APIs coming from the adapters, asking the core to refresh its flows for a given device? So in a way, like the core will push those flows, but on request of the adapters. And that will also be the case where if the adapter sees that the flows that is on the device doesn't match the one that was supposed to be there.
I think that's
stop. Go ahead.
I think that's a good idea. I think so. Maybe, there's two issues here. One is the Onos app behaving the way it should or not. But if we kind of put that one to the side for a minute, whatever the core and the adapters need to see between them should always be in sync, right? So maybe in this case, if the adapter comes back up, if the core has EAP and subscriber flows there by virtue of Onos or just remembering, repush them down, and then kind of like you described, if the adapter comes back up and needs to just ask and say, hey, this device just returned, give me all the flows with regard to this device, might be a good idea. And then deal with the Onos, whether Onos should actually push down subscriber and EAP or just EAP, kind of as a separate question.
Yeah. Any other comments on that?
I still think that's an issue because after an OLT reboot, you ideally, I don't know, do you ideally want the devices to authenticate itself, because it could, it could replace the ONU while it's rebooting. So ideally, you would want the devices to authenticate again. So if you just ask the core and repush all the flows back to the device, they would just become, operational. They're able to do all the services they were doing before. I don't know, probably that's my opinion.
Yeah, I think you should be forced to authenticate again. I mean, we could ask what the AT&T workflow requires.
Yeah, I think operators' feedback would be good.
Yeah, so in this particular case, the NIM layer kind of smooths a lot of this out, where it will see if an ONU goes away, and then north of Onos, tell Onos to volt remove subscriber. And then when the ONU comes back, it does a volt add subscriber again until it sees the EAP event. So yeah, this is where northbound orchestration kind of, implements the behavior, which may explain the difference from like 1.6 to 1.7.
Yeah, because just after reboot, if the adapter asks all the flows to be replayed again and it pushes again, the ONUs just come into service immediately. If something was spoofed behind the OLT, you would never know. So it's better to have them authenticated again.
We could make that that request conditional of an authentication happening.
It's all in this realm of the app, right? This is where when the app used to automatically run volt add subscriber on authentication, but it became clear that depending on operator needs, you may want to have some other workflow in place. So maybe, so one issue is, again, I guess if the device goes down, we do need to pull EPOL and subscriber flows. And then when it comes back up, just push the EPOL flows. And then the core and the adapter should only see that, right? If that were at least consistent, then we would at least be in a situation where we need to figure out what to do northbound But right now, that situation's kind of mismatched.
Yeah, exactly. So probably if we, once the device becomes unreachable, basically the port becomes disabled, it should just pull all the flows, and once it comes back, just put the APOL flow, allow authentication to happen, and then probably push all the. I think that looks good to me. But
yeah, and I think for the purposes of repushing subscriber flows after EAP, either you have a fully fleshed out NIM layer do that, or in some cases just a simple Kafka listener that sees an EAP event and then turns around and does volt add subscriber again. For test stubs, we've done something similar just to kind of close that loop real quick. But it may be that we just need to make sure that all the subscriber flows are gone when everything goes operational down. And I guess the question there is, ONO should be the one responsible for pulling those because it's the authority. And then the core should honor that, pull it out of its decomposer layer, and then tell the adapters, pull it out of its, actual hardware talk layer.
So how do we make that happen consistently? Do we need a Jira, or do we need something to track that?
I think so. I think maybe the question there is why isn't ONOS pulling subscriber flows when the logical device goes down or the logical port goes down? And if the core will honor that removal of those flows, then it should flow through. So I think there's a bug here in either the app or maybe a behavior change in the core. But I think kind of getting to the bottom of why the app doesn't pull subscriber flows may be the starting point for this one.
Yeah, Matt, so I won't call it a bug because definitely it looks as per design. Somebody has put in the feature, but unfortunately, I don't know the reason behind it.
Yeah. So Ken, maybe to your question, the core should restore back flows to the device as it's been told to from northbound. If northbound ONOS tells it right or wrong, then the core should basically just resend it back down what it knows as its decomposed flows when the operational status of the device or port comes back.
Well,
and
there
then
should be a trigger that calls the core to repush those flows. And would that trigger come from the adapter, or when there's certain state transition, automatically the core should do that?
So I guess the way it should work, right? If operational status on a port goes down, adapter reports it to core reports it to ONOS then pulls the flows, right? Core then pulls it out, tells the adapter that it's gone. I guess the question really is does the core make any decisions on removing or adding flows outside of what it tells ONOS? And I don't think that's something we want.
No, we don't want that.
Yeah. I think we just need to create a Jira bug right now and then track it, probably check with Saurav. I think he might have some idea about this.
Yeah, there's some history here I think we might need to discuss with him.
Yeah, let's do that for the sake of time. Because the next questions is very similar to that. It's like when we have a device state change, whenever a device changes to enable state and active, like from whatever state it was, pretty much it will be still enabled, but whatever operational state is changed but came to active, should the core send all the flows to the device. And the reverse also happens if we go away from operational state active, is there anything that the core needs to do in terms of flows on the devices?
I guess the question is does ONOS, if that operational status of the ports and device make its way all the way to ONOS, does ONOS take the action and the core just reflect it? ONOS doesn't take action, then are we asking the core to take action? And I think no. I think we just report up, and then ultimately the ONOS app needs to be the one to decide to pull the flows.
Yeah, that's my preference. The only thing I just for that to happen, we need to have a port state change as well. And I don't know if we get this port when we have a device state update. Does it always accompany with a port state transition as well?
So, Ken, the port that we are talking about here is the logical port, right?
It could be the physical ports, because it's when you're talking about in order for flows to come down, obviously it has to be the logical ports changes, which equate to the device, right?
Correct. Yeah, so at least earlier what was happening with WonderText is whenever the ONU, as in the ONU device state was changing, parallelly the logical port state was also being changed by the ONU adapter. So, but now I think the logical port has moved up to the core, and that needs to be handled.
Yeah, I think right now the ONU, if it's offer down, will offer down its ports, and then as long as those real ports make their way to the uni ports offer down in the logical device, that should do it, right? That, I guess that's the piece. The adapter has to be responsible for reporting its ports as offer down. And offer back up again individually.
Yeah, I agree.
Ken, just a time check. We've got about 1 minute left. Do we need to allocate time on Thursday to continue discussion?
Let me see. Most of the question that we have is really about flows. Maybe we need to answer the first question, like maybe get Saurav involved about why ONOS is not pushing all the subscriber flows first, and then based on his response, then maybe we can have another meeting. I think we still need to have another meeting. It's just like I don't know if we'll be talking about the same thing if we don't have Saurav involved.
Okay, thank you. So shall we go ahead and break for today then?
Yes, I believe
out
so.
Of time.
Sorry, I don't know.
No, that's fine. So Amit, I just have one thing I wanted to follow up with you on a question from Jira before we drop the bridge, just to let you know I am tracking it down. So we had a question on 1915. So I have reached out to Saurav to get some guidance on him for next steps here. So hopefully I will have some direction to give you soon. But I just wanted to touch on that since we didn't have a chance to go through Jira updates or discussions. And with that, I will go ahead. Quick check if there's anything the group needs to bring up in the last 30 seconds that we can talk about maybe Thursday if we need discussion. Okay, let me go ahead and drop the bridge then. Thank you everyone for your participation. I think it was a good discussion, and we'll talk again soon. Thanks.